m- obviously, my name is Adam Lundstrom. I am here to tell you about kind of what I do and how I got here. And but I'd like to start out, if I could, by asking, learning a little bit from everybody that's participating, and just ask if you have anything specific that you would like to get out of this in terms of like talking about training, or talking about exploring opportunities, or talking about, you know, anything in between. Because I have a ton of stuff I would love to talk about, but I want to kind of focus on what you guys want to talk about or hear about. So I would just want to open up the floor real quick. And it looks like we have 4 participants. Are there more than that? And I just only see 4 of them.
Hill High is actually a group of students all watching
Oh,
on
got
one.
it. Okay, cool. Is that like Hillsborough High School?
Yes.
Right on. Okay. All right. What's up, Hill High, Hillsborough High School? I'm glad you guys are all here. Ella, Sophia, Riley. It's really cool that we get to talk today. So I just want to open it up to anybody who has any questions or any input on what you would like to focus on a little bit today.
And
I
feel
I
free
know
to
nobody
drop it
likes
in
to
the
be.
chat or unmute. Yep, but this is definitely a conversation between all of us, less of us throwing a ton of information at you.
Well, maybe what they need is a little bit of just learning kind of a brief background of what this is, so that
Okay.
they know
what to ask, right?
Whatever I think is interesting. Thank you, Riley. Okay. Oh my goodness, Riley, you just opened a Pandora's box. Because, all right, let's start with this. I'm going to share something here. Here is this is what I do. I ride in small airplanes and push buttons and turn dials and write things down. That's a little bit of what I do. That's one of the most rewarding parts of my job, and sometimes one of the most terrifying parts of my job. I don't know if you've ever ridden on a flight in a small airplane. If you've ridden in an airplane at all, maybe it doesn't make a difference, but it can be it can be a little scary sometimes. So let's see. Ella said, what are great high school classes to take, prepare for engineering in general or specifically? That's an excellent question. IB physics. Ella, can you tell me what IB, like what IB is in physics? Physics is good.
Baccalaureate.
Oh, got it. Okay. And that is different from regular physics. How? I'm not familiar with International Baccalaureate.
I think it's
Let's
a more
see. Oh,
rigorous...
high level. Got it. Okay. Yes. All right. So let me start out. I'll back up to my undergraduate college experience. I went to Montana State University, and I studied industrial engineering, which has very little to do with flying an aircraft and pushing buttons and turning dials. But I did study physics because engineering. Let me back up and say I had a document with a lot of notes and a lot of information that I thought might be useful and or interesting to you. And it sounds like these nice ladies are going to share this information with you later, but I'm going to kind of use it as notes. So I will, Ella, I'm going to come back to your question, but I'm going to kind of give you a little bit of a narrative of how I ended up here. So I wanted to be an astronaut when I was a kid. I've always loved aerospace, space, whatever. I have had a subscription to Air and Space magazine since I was 9 years old. But I'm colorblind and I'm super tall, so I can't be an astronaut. Also, I didn't get good grades. That didn't help me either. I didn't have a lot of career guidance in high school. And I didn't really seek any out either. I just kind of did my thing. I thought I wanted to go to college. I ended up joining the Navy. And I got to work on airplanes. I did that for a bit and I thought, oh, this is gonna be a great career. And then I met a girl and followed her to Montana instead. So decisions, consequences. And then without a lot of direction, I kind of floated around. I was a cowboy for a little bit. I tied horse tack bridles and I made, bridles and halters and stuff. And then got a job. And then I was in the National Guard for a little bit as well. And then I got a job as an apprentice aircraft mechanic about the same time I met my wife, my future wife. And so then we moved from Montana to Oregon and I went to PCC and I got my my aircraft mechanics licenses there. And I thought I was going to work in remote locations overseas, helping Christian missionaries in their little airplanes that they fly everywhere. And that didn't happen. And so I experienced quite a few twists and turns in what I was doing and didn't really ever know. I knew I liked airplanes. Didn't really ever know. Thought I knew what I was going to do. Thought I knew what I wanted to do. Didn't do a lot of that stuff. So anyway, I, having been in the Navy, I had tuition assistance available. And so I decided to go back to school. I decided I wanted to be a technical writer. I've always loved to write, and I thought I was pretty good at it. So this is the first time I ever really looked into a career. And so I got information on it, and I needed to have a technical background, and I needed to be able to write, and I needed a bachelor's degree. And so I had a technical background and I thought I knew how to write, and I didn't have a bachelor's degree yet. So I went to school and I studied industrial engineering because it was technical and it was people focused, which are both important, right? Technical writing. I don't know if you've ever heard that as a term, or technical communication, but it's the practice of taking super technical information and turning it in, basically translating from engineerese to end userese. And I've always enjoyed teaching as well. It was something I didn't realize at first, but I looking back, I realized I had enjoyed teaching aspects of my job, training, coaching, teaching, even from high school. I grew up in Minnesota, and I used to teach winter survival to Boy Scouts, and sleeping outside in below zero temperatures and camping in the snow and stuff. So anyway, that kind of fit together. So I kind of slowly started to put together pieces of me, that worked well together. And so I went to school and got my bachelor's degree in industrial engineering, which I don't know if you know about industrial engineering, but it's the design and improvement of processes, of making things, or making products, or providing services as well. And I got some exposure to different to some new industries that I had never experienced before. So I worked on I did some work on healthcare business process improvement, and that sounds super boring, but it was really cool because I got to help people in small, rural, poor communities in Montana get better healthcare, because it didn't take the staff so long to make appointments or process their notes from their visits, or figure out how to provide emergency services. So it was really cool. And I thought, I might be able to do that. I think I could have. I think that I've looked back and said, I could have done that. I could have done that. And I've looked forward and thought, I could do anything. I could do a lot of things right now. Right. I'm not married to this. I feel like that less now because I'm older and because I really, really, really love what I do now. But I don't think there's ever been a point in my life where I thought I could never do anything else. You know, there's always been, and maybe that's because I'm ADHD and I thought, oh, squirrel, I could go do that, right? There's just a lot of stuff out there. So anyway, I thought, oh, I could keep doing this. I had lived in Montana for a long time at that point, and I had a little baby girl, and I was married, and I really liked it. And Montana is beautiful. And then I got a job offer at Garmin. They have an office in Salem here in Oregon, and it was like a perfect job for me, and I took it. And I worked for 3 years there, and I hated it. But I learned how to write a lot better. It was really intensive, and it was a big corporate, businessy kind of environment. And I got to do a lot more things. I got to get involved in quality and process improvement, which is a whole other industry by itself. Something you're going to run into if you spend any time in business or engineering worlds. Eventually, you're going to hear these letters together: ISO 9000. That's an internationally recognized quality system. And it's a big deal, and it's a multi-billion-dollar industry, and it's basically how to take what you do already and make it better by being very systematic and rigorous about it. And that fit with what I was doing as a technical writer, and also what I was doing, but also what I had studied as an industrial engineering student. So that was cool, and I got to do those together. And I didn't like my time at Garmin the whole time, but I really liked that part. So anyway, I worked there for 3 years. Then I live in Newburgh now, and I found a job in Newburgh that was closer to home. That was a little short bike commute, which is a big deal. It doesn't seem like a big thing, but you might find yourself spending a lot of time in the car driving to and from work. A lot of people do it, and you'd be surprised how valuable that time can be if you can get it back. So anyway, I spent a year and a half working on technical manuals for portable machining and welding equipment, which is like the exact opposite of aircraft electronics. It's only portable in the sense that you can move it by putting it on a really big semi and shutting down traffic and moving it, rather than bolting it to a 8-foot concrete floor for the rest of its life. So I worked on that for a little bit. And that company was a little financially distressed, and they laid a lot of people off. And then one of the nice things about being a technical writer is that technical communication in general, is a precious resource that it doesn't get, I don't think it gets the attention it deserves, but it's a valuable resource, and it's a valuable skill. And so, and engineers are terrible spellers also. So if you don't mind spell checking for engineers, you will always have a job. That's one of the advantages of being a technical writer. The other way I used to describe it was garbage wizard, because a lot of people, when they hear about technical writers, engineers, or executives, they think, oh, I don't know how you do what you do. It's magic, and just keep doing your magic, but go do it over there. I don't want to have anything to do with it. So I used to have I used to call myself a garbage wizard, but I value my work in that area now more than I did at the time. So anyway, I worked there for a year and a half, and I got offered another job at this small firm that I'm at now, as the technical publications manager, which just means they don't have any other technical writers, so I'm in charge of myself, and I get to decide how we do things, how we write things. And that was pretty cool, because I got to make my own decisions, and I had opinions about how to do this, how to do that. And so then I got to decide how to do this and how to do that. And kind of, it was another step up to like combine a lot of the stuff that I had done in the past, and combine a lot of my experiences and the skills I had picked up along the way. And so I was very happy doing that, but I had to give up my bike commute. I had to drive 35 minutes each way. So it was a trade-off. And those are just decisions that they have to make when you're thinking about changing jobs. You know, what is this worth it? Is giving up this worth what I'm going to gain? You know, that kind of thing. So anyway, I just passed my 8th anniversary working at Integrated Surveillance and Defense, ISD. I started there as a technical writer and the TechBubs manager. And as I worked there, I learned better what they do. Maybe I should explain a little bit what they do. So ISD provides design and manufacturing of electronics mission systems for organizations that perform public service missions like search and rescue and maritime patrol, fish and wildlife, and some military intelligence. So we serve clients in the United States and internationally. I've worked with clients from several countries, including the Dominican Republic, Colombia. Oh, counter narcotics is another big one. A lot of police, a lot of international police organizations get our help to design aircraft mission systems so they can go look for drug cartels, things like that. And I get excited about that work. I think that's important work. I mean, if anybody's read the news, right, we know that's important work. And so I believe in our work, and I don't think that everybody gets to say they do that, right? So it's pretty cool. So anyway, Colombia, Peru was my most recent international client. I just finished a project for Ukraine, but again, if you've read the news, they've got bigger fish to fry. So that one's not finished yet. I'm currently working on a project for the California Department of Fish and Wildlife, the Indonesian Navy, the Mexican Navy. I was in the Navy, and so I get a lot of Navy projects. So anyway, I started as a technical writer at ISD, and as I wrote the documents, test plans, proposals, flight manuals, installation manuals, operator manuals, and as I did training for these crews that were operating these mission systems we were installing the planes, I apprenticed into the engineering part of the job. And so after about 3 years at ISD, I started doing engineering work. I transitioned out of the writing job, and that's still my responsibility, the management of that. But I figured out, you know, I wore my industrial engineer hat, and I figured out a better way to do our technical writing was to let somebody else do it. So I found a subcontractor, another company in Sandy that helps us write our manuals now, that does it better because that's all they do. And so now I concentrate on systems engineering. And so systems engineering, I don't think it's as common. I don't think systems engineering, you know, I think a lot of people have heard of mechanical engineering, designing parts and how they work together, or electrical engineering, designing electrical circuits, or software engineering. But systems engineering, I think, is the design of, first of all, let me back up. I think maybe some people are confused about, or not confused, but I don't think there's a good definition of engineering that's commonly available. And so I like to tell people engineering is the practice of turning science into money. I'm not a scientist. I don't discover new particles or new chemical reactions, but I take scientific knowledge and turn it into value in terms of and in terms of sometimes money, right? Because money is a unit of measure of value, right? But I take science and save time. I take science and make money. I take science and move. We call it EMI, energy, mass, material wealth, and information. So I take science and figure out how to move things where they need to go in those 4 categories. And so I design relationships between components and people and the environment. And another way to look at it as a systems engineer is the engineering equivalent to an architect. Okay, so architects don't design the steel girders and the bricks and the wood and the studs and the electrical schematics. They design the overall needs of the building, for instance, and then work with the more specialized engineers to figure out how to realize that overall design. And so that is my job as a systems engineer. I determine what the requirements of the system are. First, let me back up before that. I figure out first who the people are that this will affect. We call them stakeholders. So a stakeholder is a person, well, let me back up further than that, actually. So first you have a problem that needs to be solved, right? And the problem is a problem as long as it's unsolved. And stakeholders are the people harmfully affected, the people harmed by the problem as long as it stays unsolved, or who could be harmed by the problem. And so I have to identify the problem and then identify the stakeholders and then figure out requirements for the system that will solve the problem, that will prevent the stakeholders from being harmed or help the stakeholders. And stakeholders can be customers, but they can also be, so they can be the operator, the system operator, the pilot of the aircraft in which the mission system is. But a stakeholder is also the person on the ground that you don't want the airplane to fall on, right? Another stakeholder is somebody who lives near the airport that you don't want to radiate with intense radiation from a powerful radar that is operating when it shouldn't be, or from a range finding laser. You don't want to flash somebody in the eye that just happens to be driving next to the airport if you're testing a laser, right? So I had to consider all of these stakeholders. And then once we've identified all of the requirements, then we design. I'm going to actually show you an image of a diagram that might be helpful to understand what architecting in this case looks like. This is called a system block diagram, what I'm about to show you. Okay, can everybody see that?
Not yet,
yet.
Adam, we're not.
Okay, let's see. Oh, let me try that again. There we go. Can you see that now?
Yeah.
Okay.
Oh, wow.
So each one of these big boxes here, mission, computer, keyboard, these all represent things, objects, right? And these all represent an object that meets one of the requirements of the system. And requirements aren't just stuff. In fact, some people, when they ask for help from us, they say, here's the solution we want you to make. And it's just stuff, right? It's a computer. Well, one of my jobs is to figure out how to make how to make the system work inside of all those requirements. And sometimes those requirements that the customer gives me, they contradict. And so I have to work those out and say, okay, you can have this or this. That's called a trade study. Or you can have these 3 or these 2, or you can pick 6 of these things inside this group of 11. And sometimes they say, we want you to use this computer, we want you to use this radio. Okay, that's fine, but that means that I will have to work around that radio if it gets in the way of other things. So what some people see as a solution in stuff is actually a constraint or a limitation. And that's not immediately obvious. And so we tend to focus more early on function and performance. what does it need to do? How well does it need to do it? And then we pick things like this computer that does those things to a certain performance level and within certain constraints. I can't use more than this much electricity. It has to function at this temperature. It has to be this fast, that kind of thing. And this is, I draw these in Microsoft Visio. It's a good application to know how to use for producing diagrams, and like technical, nerdy graphical images. So just a little more about this. So these boxes, this is stuff. These are components that we've selected that meet the requirements of the system. And then these lines running between them, these are interfaces. These might be, in this case, these are all signals. So we're sending Ethernet signals, we're sending video over specific signal protocols. And then anyway, this is something, a system block diagram, a functional block diagram, a physical block diagram. These are things you learn to read. And there's a lot of information.
Is this stuff that's in the plane? Because I see like the cockpit.
I'm sorry. Here, let me share that
representing. Are each of those boxes representing components in the plane?
These are all actually representing components in the mission system that we design and then install in the airplane. So let me give you an idea of what that looks like. I'll show you a photo of what these look like. This is actually me in the aircraft. Everybody see that?
Mm-hmm.
Okay, this is an operator console installed in a Beechcraft King Air 90. Happens to be my favorite airplane in the world. It's like a Corvette with wings. And this is connected to, what you're looking at is, it's connected to a really powerful camera. I don't know if anybody's familiar with FLIR. It's a company in the Portland area that makes infrared cameras. And oh, this is cool. I can flip through these. Okay. Same system with the air crew, and we're testing the system after it's been designed and tested in the lab and installed. This is another system that we built for the Egyptian Air Force that we are testing in the lab as it's being built before we install it. So you can see the 3 operator consoles here, and each operator at these consoles has different jobs. And then to the right, you got this looks like a black upside down R2D2 hanging from that A-frame guy right there. That's a FLIR infrared sensor. So that has really powerful optical and infrared cameras in it. And I've got a photo of what that looks like in here. Oh, that's my dog Freya. One of the perks of my job is I can take my dog to work with me. So she's hanging out with me on this job a few years ago.
Does she ever fly with you?
She doesn't get to fly with me. I think she would hate that, so I wouldn't want to take her anyway. This is an image of Mount St. Helens from about 25 miles away with a really powerful infrared camera. When we're actually looking at a person on, you can't see it from here, but we're actually looking at a person on Mount St. Helens from about 25 miles away. So anyway, that maybe gives you a little better idea of what these systems look like inside. This is what we're designing. This is my very professional colleague, Fred, applying a load to a console that's being tested right now. One of the things we have to do is make sure that the structures that we design are safe. And so for flight. And so we have to put these different loads on them, and we're required to do this by the FAA. Basically, we just put more and more weight on them until they break, and we record when they break, and that tells us if they're okay. I think that I am running a little long here because it's just something I do. I want to I hope that that suffices for what for kind of what I do up to this point. I would really like to go through a little bit what like what I use in terms of, you know, personal assets, and skills, experience, right? I deal with people every day, and so it's really important to exercise your verbal communication muscle and practice emotional intelligence, because you can't work together. I mean, we're dealing with numbers and drawings and stuff, but we all have to be on the same team. And so I can give you an example. My CEO and I work together on a regular basis, and we don't have the same worldview. We don't have the same outlook in terms of like of interacting with people. And I need to understand that because he's the boss. And I have learned some things from him by listening, by understanding better how my boss thinks and works, and just, you know, and just listening and watching. And I still don't always agree with him, but that makes us a better, more functional team. I think, like, how much time do we have? Are we done at 2?
No, we're done at 2:15.
Oh, okay. So we have some more time. Good.
Mhm.
But I would really like to, I have a lot of like information on, you know, hard and soft skills and aptitudes, and a lot of stuff that I want to share with you in that PDF, but I don't want to recite that. I would really like to, like, right now, focus on just like take questions and just discuss things. So I would love to hear from you guys on specific things you want to talk about.
Does anybody have any questions that they would like to ask Adam? Well, maybe while they are writing down, Adam, do you want to tell us, so when you're in the plane and you're like the project you were working on with the Fish and Wildlife in California,
Yeah.
kind of show us, like, what does that look like once you take off and you're in the air? Like, I think maybe helping the students understand what that looks like in the cockpit of
Sure.
the cockpit
Okay.
and body of the plane
Yeah.
as you're working.
So when I'm in the plane, what that means is we've been pretty successful up to that point, because we have successfully gathered requirements and created a design and reviewed it several times with us and the customer, and gotten their sign off on it, and then sent those design drawings and data to our operations department, who produces the parts, and they've built it. And they've put it in the lab, and I've tested it in the lab, and then we've taken it to the airplane. Either we've boxed it up in a crate and sent it to another country, or they've flown their aircraft to us. We have a hangar at Aurora Airport where we do installations. And so now we're at the hangar. Our very talented avionics and structural technicians have installed this system in the aircraft, and then we kind of have a ceremony we call the smoke check. It happens in the lab and in the airplane or the helicopter. The smoke check is you turn it on and see if any smoke comes out, and smoke coming out is bad. Just baseline. Smoke coming out is bad. So we do a smoke check, and then you know, we put on our party hats and toast with our Coke Zeros. And then I have, in the meantime, written a verification plan, a test plan that checks that every single one of the requirements that we identified before for the system, that the mission system function and performance and boundaries and constraints they meet every single one of these requirements. And so this verification plan goes through probably as much design work as the rest of the system, because we have to be very, very 100% and more sure that the system meets all of these requirements. But the cool thing and sometimes scary thing is we're still learning about the system, because basically it's not like we come up with a new phone and once we figured it out, we make 3 million of them. We design the system, we build the prototype, and then we install the prototype and it goes away. So we're basically dealing with the prototype, with the first one every time. And so we're always learning things, right? So as this system is installed and turned on, and we kind of flinch as we turn it on, it's because we're always still learning things. And we've had smoke come out before, because that's just learning is part of engineering. And so we try to reduce that risk as much as possible by enacting the lessons that we've learned in the past, but there's always lessons to learn, right? And so that's kind of the fun part is there's always learning going on with what we do. If we're doing our jobs right, if we're not being curious about how we can do it better or how to avoid this next time, then we're probably not doing our jobs as well as we could. So anyway, now the system is in the aircraft, and now we turn it on and it works. And now I go through this test plan. I go through the ground portion of the test plan, and we try to do as much on the ground as possible, because flying is more expensive than not flying, and flying is inherently more risky than not flying. So we try to do it as much on the ground as possible. But there are things like static electricity and buffeting and vibration and airflow that affect the mission system that we can't tell on the ground. So we have to fly it. And we have things that stick out of the airplane or the helicopter that affect the flight characteristics. And so I'm testing the mission system in the air, but the pilot is testing the plane in the air. And so we fly together, and I test all of the aspects of the mission system, the function, the performance, the constraints, and make sure it does everything the same in the air that it is on the ground. We test the range of the radios. We test the actuation of the camera. We test the focus of the camera. We test, any number of things, and then we land and toast to our survival. And then the customer is generally present with us. So we have a customer representative that is going through the test with us. So I say, okay, we're going to test this next. It works. I initial it. They initial it. We move on to the next step. We land. We sign that the test plan is complete. And that's like literally when we get paid. That's kind of one of the things that's necessary for our company to get paid for our providing our services, is that we've shown that we've delivered what we said we were going to deliver by showing that it meets all of the requirements we had determined before. So
do you have to test it in a variety of different weather circumstances and altitudes? Is that part of the process?
Yes, absolutely. Yeah, it has to, that's a performance issue. Like it has to be able to perform above a certain altitude, or, at a certain airspeed, or et cetera. I have a great question here. It looks like from Ella. Do you ever feel unsafe in your job? Feel like it has good physical safety and a good community? Let me start with that one. I work in Wilsonville. I live in Newburgh and I work in Wilsonville. And my daily commute, even though it's 35 minutes, is like through like alpaca pastures and fruit orchards. So there's really nothing like unsafe about my daily grind, as it were. I have felt a little flying in small planes is scary sometimes. So yeah, definitely. And flying in small planes with military and police organizations from countries in developing nations can also be extra scary. So I've experienced some of that. I lived in Lima, Peru for 2 months, working on a project with the Peruvian Air Force. Lima is a lot like Los Angeles. It has good neighborhoods, bad neighborhoods, and excellent food. And it's on the beach and it has a great surf break. So I highly recommend it if you ever get to travel. are unsafe places in the world, and I generally try to avoid those. But I have definitely experienced, I deal with risk in my job. That is, there's always risk. The risk only goes away when we ignore it. It's still there. We're just ignoring it. And so I have to deal with risk day to day. I have to think about physical security when we go to other countries. We work literally all over the world. Southeast Asia, Sub-Saharan Africa, North Africa, Central and South America. A lot of places that you hear bad stuff in the news, right? But another part of the equation is you hear bad stuff in the news because it's rare generally, right? Like you don't hear about every car accident in America. You hear about a lot of plane crashes, but that's because generally air travel is safer than car travel. So, okay, other facets of engineering or science you wish you would have looked further into? Absolutely, pretty much everyone. That is a great question. I love science. I love math. I love calculus. I'm not very good at it. I can't even remember, guys, how many calc classes I had to take to graduate. Okay, so I graduated with a 4-year degree in only 5 years. And that was in part because my calc classes and my applied physics classes. So if you love something, don't let not being a savant at it discourage you from pursuing it, because I love math and I'm not the greatest at it, but I even love teaching math and tutoring math, which is a side job I've had because I learn when I teach and it forces me to organize my thoughts in my head. So if you love something, don't give up on it just because you're not the 100% best at it. But yeah, I think I would have really enjoyed electrical engineering as a specialty or mechanical engineering. I work with some just superhero mechanical and electrical engineers. I don't think I would have been as good at what they do if I had pursued it. But I love working with people. And so really, I love doing what I'm doing. I love kind of the fusion of all those things. I kind of have to practice fluency in electrical design. I have to be able to read an electrical schematic. I have to be able to read a mechanical drawing and the tolerances and the measurements on a mechanical drawing. I have to be able to talk to our logistics guys and know how to order stuff and know how to read material specifications. And I need to be able to talk to customers and know how to ask them questions to find out what they actually need versus what they think they need. And that's a big difference. That's a really important thing to remember. I think the biggest component to verbal communication when we're talking is asking questions, like getting information, not just listening, but asking the right questions to get the information you need. Hillsborough High, how long did it take you to learn to pilot a plane? Sadly, I don't know how to pilot a plane. I think I could take off in a plane, but I'm not so sure about the landing part. And the FAA would be very unhappy with me if I did, because I don't have any pilot ratings at all. So if you hear about Adam Lundstrom in a plane, something's wrong. I mean, like piloting a plane, something's wrong. I am an operator. Oh, Riley, that's an awesome question. I'm an operator. I'm not a pilot. I consider myself air crew, but I'm not a pilot. And that's an important distinction. But yeah, I do get to spend time in an airplane. And I think, if I was in the right seat and the left seat pilot had a heart attack, I could probably call Mayday, Mayday and have them talk me down, but let's hope that never, ever happens. Have I ever let a contractor down, Riley? That is an awesome question. I have let contractors, I think, do you mean a customer? I'm going to assume you mean customer. And yes, I have. We have let customers down. And when we do, we try to learn our lessons. We try to figure out what happened. Sometimes we have failed to meet all the requirements, and we go back to the drawing board and we figure out, what's next. I can give you the biggest example in my experience here is I worked for the Peruvian Air Force to help them do a very important job. They, in the past, if you read some history about South America, they've had their their raft of issues with different internal political conflicts. There's a group in Peru called Sendero Luminoso, Shining Path, and they are a scourge upon the populace of rural Peru, while they claim to be helping the population of rural Peru. And so the Peruvian Air Force was trying to keep an eye on the remnants of this organization that had mostly disbanded in the 90s, that was still causing problems for people. And so we were helping them design an aircraft that could surveil these camps from a safe distance, because these guys will just shoot at planes randomly. Like, they don't like people flying over their camps. And so they need to be able to like see down and look at these places and collect information on them, and share this information via satellite communication, SATCOM, with other organizations, so they can figure out how to deal. And so we designed a system that had surveillance and SATCOM capabilities, and it didn't work very well. And part of it was there were several components. Part of it was how we wrote the contract, because the terms of the design were unclear, and I wasn't very good at my job yet. I was kind of new to the job, and we had never dealt with satellite communication before, so we were doing a lot of learning with not a lot of guidance, and in a very short span of time, shorter than normal. And so we had kind of made it difficult for ourselves. And it's the reason, and I wouldn't ever give this back because it was one of the definitive experiences of my life, but that's why I ended up spending, like, basically living in a hotel room in Peru, in Lima, for 10 weeks, because we couldn't get it right. And I had to keep going back and asking for help from home, and asking our software engineer to rewrite this piece. He sends it to me. It takes a long time because internet in Peru is terrible. Install it, see if it works. No, it doesn't. Do it again. Lots of test flights, lots of late nights, lots of delays, lots of not seeing my wife and daughter. So yes, and the consequence was the company lost money, and I was partially responsible for that. But we finally delivered what we said we were going to do, but it took a lot longer than we expected. It was a lot more expensive than we expected. But the cool thing is, the way that we operate, we recorded our mistakes, and we went back and reviewed them, and we owned them. I'm a big believer in ownership. Like, if I am responsible for something, I think it's important to go over the top and say, I am responsible for this. And even if it looks like somebody else failed to do something, I have to think about, how did I contribute to their failure, right? Like, what could I have done? What could I do next time to help them succeed next time, right? So what was my failure? What was my responsibility in somebody else's failure to deliver? And so we did a lot of that. And we have seen results from it. If I had time, I could go into how many other projects we're doing right now that are doing better in the design process and the overall business process, because we know we understand pretty well now what we did wrong, or we understand our failures from that previous project, and we wrote down the lessons, and we're required by our own quality system. Remember those letters, ISO 9000. We're required by our own ISO 9000 system to implement those lessons that we learned. Would I ever transition to learn to pilot a plane? Okay, so I think that's Sophia. Sophia, I would love to learn to pilot. And actually, I was on track to do that. I worked at Garmin and in Salem, and one of the great perks about Garmin is we had a relationship with the flying club across the street. They gave us a plane and said, if you'll install some of your awesome avionics in this plane, we'll give you a really good deal on renting the plane for flight training. And so Garmin used that, and we designed a new system for this little Cessna 206, and put just all brand new touchscreen avionics in it, and it was like top of the line. Really, really nice system. And then we got to rent that aircraft for personal flight training, and we had a lot of qualified pilots and flight instructors at Garmin, and so it was relatively, it's still expensive, but relatively inexpensive. And so I went through ground school. I don't know if there are any student pilots out there, but I went through ground school, completed ground school, got my sign off from my logbook. But then there was a long queue for flight school for going through that program. And I left Garmin before I was able to take advantage of that. And as much, I mean, it's on my list, right? Like there's a lot of things I would like to do. And one of them is learn to pilot a plane. That would be pretty cool. But there are things that are more important for my job and more important for me personally. It's not at the top of my list, let's put it that way. But I do love to fly, and I try to fly every chance I get. So military experience. So let's see. Is that Karen? Is that your question, Karen?
Yeah, that's mine.
Oh, okay. Military experience is invaluable. I was in the Navy for 5 years. One of the biggest lessons I learned in the Navy is to live with adversity. I feel pretty comfortable in a lot of situations now because I had to live in a lot of uncomfortable situations in the military, and just day-to-day stuff, but sometimes just very stressful, short-lived experiences. I also got some really cool technical training, and I got to literally sail around the world. I was deployed on the USS Nimitz for 6 months, and we went west to east from California to Florida, all the way around the world. And I lived in Iceland for 2.5 years. I was stationed in Naval Air Station Keflavik, Iceland for 2.5 years, and that was I don't even know how to describe it. It's free travel, and it's some just invaluable life experience and technical experience, and it's what paid for my college for the most part through the GI Bill. So depending on what you do, yes, military experience can be a very valuable asset. And ISD is a veteran-owned company, and most of my colleagues are military veterans. And we work with a lot of our customers are military. And so just by virtue of our experience, we are, it's easier for us to relate to our customers. It makes sense. That doesn't apply to everybody, right? Like it's not necessary. We have several non-veterans that work with us who are equally as capable, who have just different backgrounds and experiences than we do. So
is there something that your company has to requirements in order to have military contracts?
Let's see. Well, one of the important things is we work under a set of federal laws called ITAR, International Trade in Armaments Regulations. That doesn't mean we sell guns and bullets and missiles, but some of the stuff we do can be considered military equipment, and so we have to operate under those rules. We're restricted in who we can talk to about what we do when, and to work for ISD, you have to be a U.S. person, which doesn't mean citizen, but it does mean I'm not sure exactly about the rules, but basically you have to be a U.S. passport holder. We do actually have a couple of naturalized U.S. citizens who work with us from Eastern Europe and from Mexico and South America. But you have to be a U.S. passport holder to work in an organization or an industry that operates under ITAR. So that's an important one. Yeah. Let's see. Oh, here we go. Back and tell your younger self, yo, I love that question. Hold on one second. I'm actually going to refer to my notes because I wrote some, and I might even read this out. I'm going to violate my own rule and read this out because I love this question, and I probably spent more on thinking about this question than any of the other ones. We might have to end with this because it looks like we're getting close to time. Let me see. Younger self. Best, least.
And for everybody
Okay.
who was watching, we will share this document that Adam is reading. We will share that with you.
Okay. All right, here goes. I'm going to try and fire this off in the next 30 seconds. Be disciplined about saving money. Put aside a certain percentage. It doesn't have to be a dollar amount. If you only make it 300 a month, put away $3 a month. Just put away a little bit at a time. Your 30-year-old self will be grateful to your now self. Learn to say no. If you can't deliver, don't commit. If you don't agree, don't agree. If you don't understand, don't fake. If you don't understand, learn, but don't fake. And like I said before, fail well. Own your failures and view failure as an opportunity. Feel bad about your failures, but then wash your face and study your failures and figure out how to do better. And I am a youth soccer coach. I'm a USSF licensed youth soccer coach, and I've learned to be my own best coach rather than my own worst critic. I don't know if you've ever seen, you know the memes about soccer parents, right? Soccer parents are the worst, you guys. Okay, be a soccer coach, not a soccer parent. Don't be one of those yeller soccer coaches. Be a coach that asks yourself good questions. And like, how could you do this better? How could you solve this problem? Then act on the answer. And share your successes generously. Like sharing your success. If you succeeded, thank everyone who had marginally to do with your success, and that will multiply your successes. That's not just from the Oscar acceptance speeches. That's real life. What else? Don't pursue a career in a field or any field right now. It's okay. I didn't know what I wanted to do in my life until I was 37, guys. It's okay not to know what you want to do right now. Engage in some high risk growing up activity. And I mean like take crazy classes. Think about a gap year. Take crazy classes at college. Go study horse acrobatics. Like if it sounds interesting to you and you can afford it, go try it. It's okay. I am where I am because of the combination of like the convergence, the confluence of all my experiences. It's not because I just like chose like this linear career path. Okay. And I kind of like where I'm at. And there were people wonder about salary. If you like what you're doing and you're paying the bills, you're doing better than most. I know I have met personally a lot of wealthy people who are miserable, and that's not just a sop to make, us people who are in the 1% feel better. It's true. So think about value and wealth in other ways than, how much you're making. And what else? Oh, when you start job interviewing, interview the interviewer, right? Like you are offering them something. They're not just offering you a job, you're offering them your services. Something I like to do is when I'm about to interview, for a job, I like to find employees on social media from that company and then like literally cyber stalk them. Okay. Not in a creepy way, but like you find out about them, read about like, do they post about their job? Find out what you can about the job, find out what you can about the CEO, right? Like what about the company culture, things like that. I think we're over time. So I don't want to, we could go on if we, if we're allowed, but I don't want to step on your schedule at all. So, oh, let's see. Wait, is there more questions?
Does anybody have any last questions, students? Because if you're the ones who this is your event, so if Hill High, Ella, Sophia, or Riley, if you have any questions, ask now. Otherwise, we will just we'll let Samantha wrap it up. Oh,
Is it very hands-on? It can be. I spend a lot of desk time, sadly. But one thing I've learned is that the grind is important. Like just grinding on a task, even if you don't like it, sometimes it can get results. So it's important to learn how to manage that kind of task. You know, work on it, take a break, keep going, right? Figure out tools to help you focus and stay sane. Like I showed you that diagram that took hours and hours and hours over days and days and days, and it gets a little monotonous sometimes. But I walk my dog. I go for a bike ride. I do push-ups. Things like that. So it can be hands-on, and those are the fun times. But hands-on can look like different things too. Like if you like what you're doing, if you're like working on the application that you're there for, right? Like I could call drawing diagrams in Visio, I could call that hands-on. But you have to compare that to like email, right? Like everybody's got an email, everybody's got to, pay bills, that's not hands-on. But if you like what you're doing, and you're doing what you're there for, that, you expand your definition of hands-on a little bit, I guess I could say. I didn't look at it a lot, but I do work in a laboratory, and I kind of get to play with like grown-up Legos. So I get to pull electronics out of a cabinet and set them up and connect them to power, and do my own little smoke checks, and just try and like build stuff, see, oh, can I get this to work to satisfy this requirement? So yeah, there's some hands-on stuff like that. Yeah, I think I get to have a lot more hands-on time in what I do than some people do. Anything else?
Any other final questions? Now is the opportunity. Or if there's questions that you think of later on that you are dying to know, we're happy to connect you with Adam.